Hi, I'm Tim Howland from Johnson Outdoors, Minn Kota. This video will show the complete disassembly reassembly for a 3¼ inch diameter motor unit. 3¼ inch diameter motors can be variable speed, 5-speed, freshwater, or saltwater, but the disassembly reassembly procedure is the same for all. We'll use this Endura 40 model as an example for our disassembly reassembly procedure of the 3¼ inch diameter motor lower unit. We'll begin our disassembly procedure by removing the prop nut, washer, prop, and drive pin. Use a 1/2 inch nut driver to remove the prop nut. If the prop drive pin is sheared, a blade screwdriver can be used to hold the armature shaft stationary, while a 1/2 inch open end wrench is used to remove the prop nut. After removing the prop, we'll inspect the area behind the prop hub, checking for any evidence of monofilament line that may have gotten wrapped around the armature shaft or prop shaft, damaging the prop shaft seals. If any evidence of monofilament line is found, plan on replacing the 2 seals in this plain end housing assembly. As an aid to reassembly, we'll use a small piece of masking tape between the center section and front end bell, then use a razor knife to cut that tape right along that seam between the center section and the front end bell, just to make sure that we get the center section reoriented properly for proper or correct armature shaft and prop rotation. Next, we'll use our 1/4 inch nut driver to remove the 2 motor through bolts. Remove the motor plain end housing. Simply pull it up and off the end of the armature shaft. Use a short length of PVC pipe to hold the armature in place while the center section with magnets is removed. Use our brush spreader tool to hold the brushes in place while the armature is removed from the front end bell assembly. Remove the armature and examine or inspect the armature commutator for any discolored areas or evidence of arcing or sparking. We can also use a VOM to check the armature commutator for continuity. The commutator should show continuity from each comm section to all the other comm sections. The armature should show no continuity from the commutator itself to the armature shaft. If continuity is not found from each comm section to all the others, the armature is faulty and will need to be replaced. Also, if continuity is found from the armature commutator to the armature shaft, the armature is faulty and will need to be replaced. Examine the motor brushes for any evidence of excessive wear or water damage. If they are found to be worn or badly damaged, they will need to be replaced. Remove the 2 brush springs and examine them for any damage. Make sure that the springs have plenty of tension and that they're clean and show no evidence of any damage or rust. Again, using our 1/4 inch nut driver, we can remove the 2 brush plate mounting screws. Remove the brush holder, making note of the position of the red and the black motor leads. Because this is a 5-speed motor, you'll notice that there are 2 wires connected to the brush on the red brush side. There'll be a yellow wire coming out of the speed coil, which is located in the lower unit, as well as the red positive brush lead. We'll disconnect both the red and the black leads from the brush plate assembly to replace the brushes. Use a small pointed tool to depress the barb on the brush to remove the brush itself from the brush holder. you'll notice that there are 4 wires coming down from the head to the lower unit. A red motor brush lead, a black motor brush lead, and a yellow and a white speed coil wire that go down into the speed coil that's potted into the nose or the front end of this front end bell assembly. Coming out of that potting material is a yellow wire that will connect to the red brush lead. The speed coil is used for the lower speeds of a 5-speed motor. The first, second, third, and fourth speeds use that resistance coil or speed coil to slightly drop the voltage for the first, second, third, and fourth speeds. Fifth speed applies full voltage directly to the red and the black motor brush leads for full power, highest RPM. Reconnect the motor brush lead, placing the red wire on the bottom of the brush plate assembly and the black wire to the top side or the top brush of the brush plate assembly. The brush plate assembly can then be reinserted back into the motor unit for reinstallation. After reinstalling the brush plate assembly, install the brush springs back into the brush pockets. Be sure to use the large oval-shaped end of the spring into the brush plate assembly first. Next, we'll insert the brushes into the brush pocket, compressing the spring as we insert the brush. With the brushes back into place in the brush plate assembly, the armature can be installed. Remove the brush spreader tool, making sure that the brushes are free to move and that the brush shunt leads are not contacting or touching the inside surface of this front end bell assembly. Check to make sure that the armature is free to spin and that the brushes, again, are contacting the com. Remove the old O-ring and replace it with the new O-ring. You'll notice that on the 3 1/4 inch diameter motors, 2 different size O-rings are used. One O-ring that's slightly larger in diameter is used on the center section itself. A slightly smaller O-ring will be used on the plain end housing. We'll also want to examine the magnets that are bonded into the center section. Check them for any evidence of breakage or cracking. Replace if any evidence of damage or cracking is noted. The center section can then be reinstalled onto the motor assembly. Again, using our short length of PVC pipe to hold the armature in place, we can slip the center section with magnets over that PVC pipe and lower it into position on the motor assembly, lining up the cut edges of the tape. If this center section had not been marked and you were to reassemble it just 180 degrees out of position, the motor will run backwards. Reinstall the plain end housing, making sure that the steel thrust washer and nylotron thrust washer are in place on the armature shaft. Install the plain end housing over the armature shaft and drop it into position. Orient the openings for the through bolts at the 3 o'clock and 9 o'clock positions relative to the motor skeg and shaft. Next, we'll remove the old O-rings from the motor through bolts and replace them with new. A small amount of grease should be applied to these O-rings to prevent damage when the through bolts are tightened. Start the screws in the pockets provided in the nose cone. Give them a couple turns by hand to make sure that the screws are properly started and are not cross-threaded. Use the 1/4 inch nut driver to tighten the 2 through bolts, alternating from side to side as the through bolts are tightened. On 3 1/4 inch diameter motors, the through bolts should be tightened to about 35 inch-pounds. At this stage, before installing the prop, we can give the motor a little test run just to make sure that we have all 5 speeds. We can actually operate the motor for a short period of time out of the water without damage. Reinstall the drive pin, making sure that the pin is not bent or damaged in any way. Next, we'll install the prop. Prop washer and prop nut. It's a good idea to apply just a small amount of anti-seize or grease to the threads on the end of the armature shaft as an aid to future disassembly. Install the prop nut and tighten it back into position using the 1/2-inch nut driver. This completes the disassembly reassembly procedure for a 3 1/4 inch diameter motor.